Hi folks, today we are doing batch inferencing on Exosphere. So we have a CSV file which has some 15 files which are file paths which are listed, and we want to parse these files using the batch inferencing API of Gemini. So as a part of this, we would like to parse the files, create chunks, send a request to the batch inference API, poll the results because usually batches take around 24 hours to complete. Given each of the responses in the batch, run validations on each of the individual responses and write results as per the output to the database. So we have nodes which are defined exactly for that specific use case. And now let us take a look at how the graph for this workflow looks like. We have the nodes, inputs, and the next nodes which are defined. One interesting thing is in the implementation of the polling node, which should be rescheduled each time this batch job is not completed. So to do this, we are using something called signals in Exosphere. So what are signals? These are signals which any node can raise, which alters the state of execution of a graph dynamically. So here it is raising something called a requeue after signal, and every time it is run, all it does is it looks at the results of the specific batch. If it is not completed, it raises a requeue after signal. Given the signal, the Exosphere state manager then requeues the specific state after the given time duration, which in this case is 30 seconds. If the status of this task would be completed, we would just pass on to the next result as such. So now once we have the graph which is defined with our retry policy, our store config, which is the data which could be accessed by any of the states across the execution, and our secrets, we are now good to go and trigger the graph. So let me just walk you through the trigger graph method. So this is a simple trigger graph where we are just initializing the store that we talked about earlier, and this would trigger the workflow. Now I triggered this around yesterday so that we can do this demo today, because usually batch jobs take around 24 hours to complete. So as I said, we had a CSV file input and with some 15 files, and the batch size was 5. So we created 3 chunks, and each of these chunks was then parsed given the extension which could be PDF, doc, or Excel for this case. And with this data which was parsed, we create a batch request for Gemini and send that across. And then we do the polling as we talked about earlier. This polling took around 24 hours. And once the job is completed, so you can see each of the polling node is then split into 5 nodes, which is each node is containing a specific response from the batch. And as per the response, we then run validations. And if the validation is successful, then it is written into the database, or it is sent into failure handling, which writes it to a different CSV which can be picked up by the next job. So that is how this works, and this graph of execution is what spawned out, and all you needed to do was define the singular graph with these nodes, and then the state management, parallelization, fan out, and failure handling is managed in place by Exosphere. Another quick point here is if you do not want to do batch, right? If you want to do just synchronous processing, all you need to do is just split out, replace few nodes, and instead of the batch processing node, we have a synchronous processing node, and we have a file distribution node. So given the CSV file, now we are creating independent states for each of the files at the very get-go, and instead of calling the batch API, we're calling the real-time API here. And this is a simple chat completions called into the AI model implementation, and everything else is pretty much the same. And you can see that we triggered this graph with a different namespace, and let us just quickly take a look at the graph execution of this one as well. So these are the nodes, and you see the other remaining nodes are exactly the same as the batch one. Let us just Great. So I ran this for around 3 files just before this demo, and this is exactly what happened in the very beginning. It split it into individual nodes for each of the CSV or each of the file paths, and we ran a real-time API, did the validation on the response, and wrote it to the database. So this is a much simpler use case, but can be built exactly on top of the async one just by replacing a few nodes. So yeah, that's it. Thank you.